So this is chapter 8.3 of pre-calc. We're going to talk about dot product today. So dot product, guys. Dot product. There's a few things that we're going to realize about this dot product. The dot product is between two vectors. So I'm going to say that vector A is A1, comma, A2. Vector B is B1, comma, B2. Okay? And the dot product itself looks like multiplication. So A dot B. What it really means for us is that it's A1 times B1. I'm going to not put a dot there because it's times. B1 plus A2 B2. That is the dot product, guys. Now there are a few things about this dot product that I would like to talk about. Number one, the answer or the dot product between two vectors is always a scalar. It's just a number. It's the x's times the x's, the y's times the y's in a way. And so you end up with a scalar number. We also want to talk about that if A dot B equals 0, then we would say that our vectors are orthogonal. Orthogonal. Fancy word for meet at 90 degrees, or aka they are perpendicular to each other. So, something we can use from this is that if you are performing the dot product and you get 0, you know you're dealing with angles, or vectors, sorry, that are at 90 degrees to each other, and they're orthogonal. If it's something other than 0, they're not orthogonal, and it means that they are not right angles to each other. So our first example, I want you to take vectors u and v, and I want to find the dot product. And once you have the dot product, I want you to tell me, are these orthogonal to each other or not? So I'll give you guys some time for that. So remember, dot product would be u dot v, which would be 3 times negative 5 plus negative 2 times 1, right? Which is negative 15 minus 2, which is negative 17. And we would say not orthogonal. Now, let's just quickly give an example of one that is. U is equal to negative 2, negative 3. V is 9, negative 6. Guys, find the dot product of these, and in this case, they will be orthogonal. But verify that. U dot V is equal to negative 2 times 9. Plus negative 3 times negative 6, so negative 18 plus 18, which is 0. And since the dot product is 0, they are orthogonal, which also means that they meet at 90 degrees or right angles. Guys, a third of your homework is doing that. Okay, so now we're moving on to the properties of the dot product. We have the commutative property. The commutative property, if you remember back to your real numbers, We have to add to this, guys, on our properties. U, V, W are vectors. And we're going to say that K is a scalar. Okay? So, commutative just means that U dot V is the same thing as V dot U. This should make sense because if A1 times B1 is going to be no different than B1 times A1, then you move on to the next set and it's A2 times B2. And that order doesn't matter. So the dot products are commutative, means you can flip their order. Distributive property. The distributive property says that if I do the dot product of U with the fact that I want to add two vectors, I can take the dot product of, or just kind of distribute that dot product in. So I can take U dot V plus U dot W. Distribute that U as a dot product in. It's kind of like multiplying in. The next one is scalar multiplication. Scalar multiplication uses K because we're calling that a scalar. And what happens if I have scalar multiplication of a dot product? The cool thing is that just like normal multiplication, I don't think any of us, when multiplying those together, if they were all real numbers, K would not be used more than once, right? Once you bring it in, it goes to the U or it goes to the V. Same thing here. And so it's going to be KU dot V, or it'd be U dot KV. I am not going to give both of them a K value. It's the same lines of 2 times 3 times 4. I don't sit there and say that the 2 gets distributed to the 3 and to the 4, because then I have twice the value that I had needed, or should have.
And that's only if we have like only 2 vectors?
Correct. If you have a third vector in there, which you wouldn't have a dot product with a third vector though. Dot product works with 2 vectors. The 0 vector dot product says 0 dot U is equal to 0. The 0 vector times any vector is 0. So dot vector doesn't matter if it's a scalar or if it's a dot product. And the last one, which is the one that we're going to most likely use, it says that U dot U, so the dot product between a vector and itself, is equal to the magnitude of U squared. Now I'm going to modify this for ease of use. What happens if I wanted to solve for the magnitude of U by itself? What do I have to do to both sides? Square root, right? Square root, square root. So if I did that, wouldn't that be the square root of U dot U equals the magnitude of U? That's the same formula, I just square rooted both sides. In our problems, I'm going to ask you for the magnitude of a vector given or finding it based off its dot product. So you're going to take the dot product with itself and then take the square root. Done. Okay, this example, I want you to find the dot product, or use the dot product, sorry, not find the dot product. Use the dot product to find the magnitude of B. So hence, I'm going to go back real quick. We got this formula, and I said, hey, here's this magnitude. So I solved it for the magnitude by taking the square root. I need to do this. I need to take the dot product with itself and then square root it. So that means I want to do 12/16 dot 1216, right? And square root the whole thing. That would be the magnitude of b. And when I do the dot product with 12, 16, 12, 16, I end up with the square root of 12 squared plus 16 squared. Square root 144 plus 2. To what? What's 16 squared?
Yeah, just write a big number.
Equals the square root of 400, which actually equals 20. So the magnitude of b is 20. Okay? So another section of your homework is doing exactly that. The last section. If they're not orthogonal to each other, which means they meet at right angles, they must meet at something else. So to find the angle between two vectors, angle between two vectors, we use this formula. Cosine theta is equal to a dot b all over absolute value or magnitude of a, magnitude of b. And those are multiplied between those two.
Aren't they the same thing?
A is vectors a and b, so it could be any two vectors. This will allow us to figure out the angle between our vectors.
Yeah, but I mean, like, isn't like
In this example, I want you to find the angle between these two vectors. Now, if you happen to do the dot product, because that's part of our formula, and it's 0, you know it's 90. Boom. Done. If it's anything else, we know then that we have to find it. And our formula, remember, is the cosine theta equals u dot v all over the magnitude of u, magnitude of v. I'm changing it because now it's not a's and b's, it's u's and v's.
can you use the magnitude formula?
Magnitude formula is the first part squared plus the second component part squared, square root. Now, if you notice, this is not plug and chug, put the numbers in, and it gives me an answer right away. To find theta, I eventually need to take the inverse cosine of this ratio. That means the ratio has to be between what two values? Cosine has the biggest value of 1 and the smallest value of -1. Guys, cosine is goes up and down between -1 and 1.
Yeah. So we square both 5 and 2. So we're in the u first, right?
If we okay, we gotta do the dot product first.
Well, everybody knows there's not a dot product.
You have to do the dot product.
-20.
So this would be -5 times 4 plus -2 times 4. All over square root of -5 squared plus 4 squared. Second one is not 4.
Yeah, it's 2. That's what it is.
2 squared. This one is 4 squared plus 4 squared. -28 over square root of 29, square root of 32.
Quick maths.
You have to use your calculator on this, obviously. What do you get when you take negative 28 divided by the square root of 29 times the square root of 32? Make sure when you put this on your calculator that you're doing the square root of 29 times the square root of 32 at once, in parentheses, before you actually divide it into negative 28. Otherwise you're going to get a weird answer, not the right one. Ends up being cosine theta is equal to what? Negative point.
Negative 0.91.
I've been getting about negative 0.92 for the rounding.
Yeah.
Okay. Is that an acceptable range for a cosine?
Where did I go wrong?
So, let's take a look. Remember, cosine exists in the first quadrant or the second quadrant for inverse. It's negative, so we are actually focusing on the second quadrant. So your angle happens to be 4 theta. If you take the inverse cosine of that, cosine inverse of negative 0.92 equals 156.9, give or take, degrees. That is the answer.
That's a lot of numbers.
Now, let's visualize this. I'm going to move some of this stuff aside here. Okay. Remember that vectors in themselves can be moved around, but they can't change their direction or their magnitude, aka length, correct? So that's why we were able to join vectors together, tip to tail, or tail to tail, right? So, if I start at that particular point right there, and I apply u, wouldn't that mean that I would want to go back 5 and down 2? That's u right there. Can people generally agree that that would be the vector u? Go back 5, down 2, because I'm in rectangular component form. If I start at that exact point and go up 4 over 4, or over 4 up 4, I'm here, here. That is vector v. The angle between them, guys, is right there. Does that look to be about 156.9? So it's a positive angle between the vectors. I think that's kind of cool. That's all I have for you. So, homework 8.3, page 506, 1 through 23 odds. Have a great day.